I wanted to first start out and welcome everybody and thank everyone for joining us tonight. My name is Bob Clark. I'm the Associate Regional Rep for the Sierra Club here in Missoula. In just a couple minutes, I would be introducing Bruce Hamilton, who's the Sierra Club's National Deputy Executive Director. But I won't be doing that today because I have some bad news and some good news. And the bad news is that the Missoula Airport has been closed for most of the day. And Bruce Hamilton has been in Salt Lake City Airport for the most of the day. I am, however, very excited to be able to say that I was able to get a hold of Dr. Steve Running from the University of Montana, who has some new data and materials that he can share with you. And Dr. Steve Running is going to do a presentation for us this evening, stepping in so graciously for Bruce Hamilton. So I really appreciate that, Steve, because we were obviously put in a pretty bad predicament. First, I'd like to say a few things about the Sierra Club for those folks that aren't aware of who we are and what we do. Since 1892, the Sierra Club has been working to protect communities, wild places, and the planet itself. We're the oldest, the largest, and the most influential grassroots environmental organization in the United States. We have nearly 800,000 members nationwide and about 2,000 members here in Montana. We are dedicated to safe and healthy communities in which to live, smart energy solutions to combat global warming, and protecting America's wild places. In a climate change world where changes to wildlife and their habitat are already beginning to be documented, wildlife will need to adapt to these changes in order to find suitable habitat, making core habitat, winter range, and corridors all the more important. Our speakers tonight, but particularly tomorrow, as you've all got schedules, will present information that will help all of us to understand the relevancy and the urgency for fish and wildlife, as well as for our way of life. After this evening, we really would invite you to stay. We've got a reception planned with beer and wine and soda. There's going to be some food as well, and an opportunity to mingle with folks, and that will go on till about 10. So you're welcome to stay for that. The presentations tomorrow, as you can see from your schedule, are going to range from a talk from Craig Jordanay, who is with the Montana Fish, Wildlife, and Parks. He's going to talk about residential development and the impacts that can have on fish and wildlife. We've got Jack Tucholsky is going to talk about native fish recovery, the importance of riparian buffers. We've got Michelle Landquist, who's new Missoula County Commissioner, Brianna Randall, who's with the Clark Fork Coalition, and Hal Harper from the Governor's Office was scheduled to present, and he called me this afternoon and is not able to make it. So we now have Karen Miskey, who is the Executive Director of the Flathead Basin Commission. I also wanted to mention that Monica Fellow with the Sierra Club's Grizzly Bear Ecosystems project in Bozeman will be doing a demonstration on the proper use of bear pepper spray, and there's a display back there that we've set up that the Sierra Club has partnered with a lot of other agencies and organizations to educate the public on. And there are, besides myself, there's a few more employees for the Sierra Club here in Montana. Monica Fella, if you'd please stand up. Monica Fella is in our Bozeman office, and she's been with the club about 8 years. Paul Shively, is Paul in the room? How about Brad Hash? Brad over here is a recent hire working on our coal campaign out of the Missoula office. And Paul Shively's probably out there, but you'll see him later. Most of you probably already know him. The Sierra Club has an active hunter and angler program. I really wanted to mention that. And it's aimed at connecting up the 18% of our members that hunt and fish. Often people think of the Sierra Club as an organization that doesn't support those types of activities, but we do. Many of our members do hunt and fish, and we do want to protect the wildlife and the habitat that's out there. And so that's something that's very important to us. An important component of what we call our climate recovery campaign is building habitat resiliency on our public lands. And that's what Bruce would have been presenting on. I know that Steve can touch on some of those issues, but it's not his particular line of expertise. However, we are very, very happy to have Steve here. Steve's a UM forestry professor, and he never dreamed that he could help earn a Nobel Peace Prize, from what I understand. But that all changed when Al Gore and the authors of the 2007 Intergovernmental Panel on Climate Change report took home the coveted prize. And as lead author of a chapter about the ecological impacts of climate change on North America, he snagged part of the prize for himself and the University of Montana, I might add. The U.S. government nominated Running in May of 2004 to help write the IPCC report, and over the following 2.5 years, his team of Americans met with others from the 180 IPCC member nations at the conferences in Austria, Australia, Mexico, and South Africa. The final report, which presents strong evidence that humanity is artificially warming our world, was unveiled in Brussels in April of '07. The report is available online at www.ipcc.ch. That's www.ipcc.ch. And Steve has worked at the University of Montana since 1979. He directs the College of Forestry and Conservation's numerical pterodynamic simulation group, which has crafted software for NASA's environmental monitoring satellites. He also travels extensively to spread the word about climate change. He contends combating climate change is the monumental task of our time. And I would agree with Steve on that. And so I hope that you will all give Steve a very warm welcome and be as appreciative as I am that he was able to step in this evening on such short notice and give a very powerful presentation in lieu of Bruce Hamilton being here. So thank you, Steve, and please welcome Steve.
I don't mind doing this. It is pretty amazing that I was sitting around on a Friday night with nothing to do. What concerns me more than anything when I speak in Missoula is that you've probably already heard this before. How many of you heard me speak before in town? Yeah, that's what I was afraid of. So I have to come up with something new. All right, let's see how we do. No, I figured and I did get a call from Bob, I think at 4:20. So if this isn't well rehearsed, we know how that goes. I did figure an audience like this would be fully aware of all the big global trends. And so I thought, okay, I'm going to pull all of that from my normal public talk. And so I've really tried to build a talk that gets right to what I see some real key issues around here. And I won't go through all the standard graphics. I have enough graphics anyway, but I don't go through any of the global part. So with that, we'll see how well I do on our notice. I can't help but start with this one, because in the last few weeks, I'm stopped at the grocery stores, I'm stopped on the street, running. It's cold out. What happened to global warming? And they're only half smiling. And so I feel like maybe I need to revisit this concept again. So let's revisit this one. What's the difference? I really want I started using this graph about a year ago, this conceptual graph, to help people think that in any given point you have a distribution of temperatures throughout the year, from the coldest temperatures in, what did I do with there it is. I knew I got this out for a reason. from the coldest, oh, having two. How am I gonna do this? Maybe this isn't gonna work so well. I'm not, see how unrehearsed this is already. Well, I don't think I could steer them both at the same time. So, no, the point I want to make here is that with a changing climate, I hope everybody understands that every single day isn't warmer. We still have a distribution of warm to cold days, but this distribution moves to the right, moves warmer. And so what you end up with is a change in probability of particularly the tails of the distribution. And so less of these cold periods, more of these hot periods, but most of the time still right in the middle, normal temperatures like we would have expected without climate change. And so we don't expect the climate to be different every single day under climate change, but we do want to look at what's happening to these extremes. And so taking a look at the cold end of that graph, this is how many days per decade that low temperature in Missoula would go below 0 Fahrenheit. And to just jump to the, you look at, this is days per decade, so the average for most of the past, around 100 days per decade, or about 10 days per year. All right? Look at how far we've now dropped to where we're only getting 2 or 3 days per year below 0. How many days went below 0 in December? I think it was probably 4 or 5. Was it more than 5? I was out of town is the problem, so I don't actually know. But I think it was 5 or maybe 4. And so we'll see how we do the rest of the winter. But recognize that our average for many decades was around 10 days per year going below 0. And so I found it kind of ironic when people stopped me and talked to me about how exceptional this cold weather was back in December. And you start thinking, this isn't exceptional. This is the way it used to be. And any old timer older than me that's grown up here, I'm sure would love to tell us tales about how bad it used to be. And the statistics show it. And so now when we get a few days below 0, we think global warming stopped. So I'm sure you all don't, but a lot of people on the street seem to want to talk to me about it. And of course then the other end of the distribution, we're seeing evidence that we're getting occasions of dramatically higher temperatures. And of course, our July from hell, we're 11 days above 100. You know, in the decade of the 90s, we had less than 11 days in the entire decade, and we did it in 1 month. And so don't these two graphs look just like that shifting distribution that I showed? A higher probability of the warm events, a lower probability of the cold events, and all in the middle are just kind of the day-to-day, a more average climate. So what I'm seeing in Missoula fits the sort of classic temperature shifting theory that conceptual graph showed. Another principle that I think all of us, and including myself, need to just think through better is basically how small the atmosphere is in the Earth system. You know, when we think about the day-to-day weather and recognizing that the 5-day forecast that we see on TV at night, the 5th day is forecasting air that's over in Siberia right now, coming our way. And I actually found that one of these space shuttle images I decided was really a pretty good illustration. Look at how absolutely onion skin thin the atmosphere is in this oblique shot. And one of my friends is an astronaut, and he's gone up twice, and he says it really is remarkable just how skinny, how teeny the atmosphere is compared to the Earth. And you get a sense of that when you look at it on edge. In fact, I was reading about one of the satellites that measures profiles of atmospheric chemistry. The way they do it is looking at the edge of the Earth. And so they're literally spectrally looking at that edge, with the background being deep space. And so the atmosphere is not very big. It doesn't have very much capacity at all, even though it delivers our day-to-day weather to us. So we feel like it's very important. It is for the weather, but it is not for the climate. It just doesn't have enough capacitance to do so. And what we now know in earth science is the ocean is by far and away the heat capacitance of the Earth system. And in fact, a major paper calculated that the additional heating in the last 50 years, the additional heat content the Earth system has absorbed because of the greenhouse gas enhancement, 90% of it is in the oceans. And you see the atmosphere amounts to 3%. And so when we look for climate trends, not weather trends, but climate trends, we now know to look at the oceans and try to better understand the ocean heat content, the ocean circulation, and these ocean dynamics that are then delivering our trends of climate to us, not weather. Now, having said that, here's what the ocean temperatures right upwind of us have done. Now, this is right off of Victoria, and you see that in the last about 30 years, maybe even 20 years, we've had a substantial acceleration in the warming of the Pacific Ocean right off our coast. And so both on a global scale, we can look at higher ocean temperatures, and even straight upwind from us, we can also look at higher temperatures. Now I'll pop through these real quickly for those that haven't seen these talks. Some of the trends, 50-year trends of our major cities around Montana. Annual mean temperature for Great Falls, Kalispell, Billings, Missoula, Bozeman. You see on the order of 1.5 to 2 degree Fahrenheit increase, except for Great Falls, where they keep moving the darn station. And so that's actually a meaningless statistic there. When I first did this graph, I was speaking in Great Falls a number of months later, and I asked the audience, what in heck is going on here? Well, at least 4 of the old timers knew right away, and they told me. And they'd moved the station 3 times. So here's the precipitation trend that we see around the state, and it's important to recognize we have a clear warming trend in temperature. We do not have a clear trend in precipitation. Some of the stations have gone up a bit, some have gone down a bit. We've looked at dozens of other stations that don't fit on this graph, and you see the same scatter. There's no trend so far in our precipitation in the state. There is a clear trend in snowfall, though. And you see up on top here the overall trend that this graph shows over 50 years. And you might notice Missoula is the steepest trend down of all these stations. And based on this trajectory of loss in annual snowfall, we may, by 2050 or 2060, start having winters where we get no snow at all. Now again, that won't be every winter. Some of the winters will still get snow, but I imagine that we're only a few decades away from winters now and then that have no snow at all. the biggest trend of all in temperatures for Montana seasonally are the early spring temperatures. And these March increases are just unbelievable. They're just huge, 5, 6, 7 degrees Fahrenheit warmer in March across the state. And we've looked at this in many, many other stations also. And so this is a very clear trend across the state. And this is good news and bad news. It's good news for late winter ungulate survival. I don't really expect we're going to get those late winter die-offs that we used to get, where we'd have piles of hundreds of dead deer and antelope piled up that from winter kill. The way our winters are ending so much earlier and very strongly, I really think we're not going to see nearly as much of that as I remember when I first moved here 30 years ago, that about once a decade there'd be a serious winter die-off of the big game populations. And so that's the good news part of this. The bad news part of it, of course, is if you're a skier or an ice fisherman, and of course this then propagates into the summer, and so which we'll talk about later. So this, to me, illustrates that you might say our pivot point between winter and summer is kind of our snow melt time, and I really see that changing pretty substantially, and with every evidence it'll continue to change. And I like to use this satellite image to get people to think about how dramatically different a surface is when it's snow covered and when it's brown. And we all see this every day, but do you ever think about the energy partitioning that does? When it's white, it's about 80% reflective, maybe 60% when the snow gets dirty. But it's like a mirror reflecting the solar energy right back into space. But the minute that snow melts and it turns brown, that 60 or 70% reflectivity drops to 10% or 12% reflectivity in a matter of days. That is an exceedingly abrupt transition for the energy budget of a surface. In fact, there's really no way you can do it more dramatic transition than that. So I see this, our climate is very sensitive to this springtime snowmelt period, and I think that's where all of our climate change propagates from around a place like Montana, is the spring snowmelt period. And so if we have a year like this was actually the day that the IPCC report, first report came out, and one of the TV stations wanted to interview me, and I said, let's not sit in my office, let's go somewhere. And this is, you'll notice, 7,000 feet on a north-facing slope in early March. And when we have winters like this, we know that the summer's not going to be much fun. We know we're going to be in trouble for water and irrigation, and we know we're going to be in trouble for wildfires. And so nowadays, we're really seeing that the most important predictor we can look at for our summers is the spring snowpack and when that spring snowmelt occurs. And so, of course, last spring was glorious. And it's amazing how many people stop me. I get stopped in the streets a lot. Eh? Maybe that's why I try to stay on my bike. It's amazing how many people stopped me last summer saying, "Isn't this summer great? This is like the good old days. This is like the Montana summers of old." And it really was. It wasn't too hot. We didn't have tons of fires. There's water in the rivers. And yet, the sad thing is now that seemed like an exceptional year, and it used to be a normal year. And that's what's kind of unnerving, is we're still going to have good years, but I'm afraid we're in for progressively more of these less good years. while we talk about winter snowpack and early snowmelt, we did make a projection of this that I don't think I hope the Morrises aren't here, the snowball owners. They're gonna pull my lift ticket. But I'm afraid in 50 years, this is going to be the March snow line. And, you know, the lodge is right here. And so you really start wondering 50 years from now if Snowbowl can be a viable ski area, particularly these south and west facing runs. I just don't know how they're going to be sustained. And of course, we've already lost Marshall Mountain to just not being able to get enough snow. And then there's this Lolo Resort that has ski runs all the way down almost to the valley bottom. And I don't think they've ever heard any of my lectures because I don't think they'd waste their time cutting those ski runs if they had. Because what we're clearly seeing already is a trend. This is a data set from the last 50 years, so this is not a model projection. This is a trend we're already seeing, that more of the winter precipitation comes as rainfall and less as snowfall. And in fact, just a week ago when Snoqualmie Pass was closed over towards Seattle, did any of you see the pictures of the ski area where the mountains slid out at Hyak? I used to ski at Hyak as a kid. And this isn't an avalanche, it was a mud flow. And it took out a couple of the lift standards. So it literally took the core of the ski area mountain and slid down into a bunch of cabins. And that's because we're getting more of this winter precip as rain and less as snow. And this is occurring throughout the West. There is a major study in Science Magazine just last February that summarized the trends in April 1st snowpack. Here's for us, the Northern Rockies. And we're clearly seeing not only less snowpack, but it starts melting earlier. And so by April 1st, part of the winter snowpack's already gone. It used to be, they defined April 1st for measurement for the old SNOTEL measurements as the period of the peak snowpack for the winter before it started melting. And so for all the water management, there'd be a big push to go do the snow survey, the snow survey measurements, ski out and put the poles in the snow. I tried to get one of those jobs for so many years. I never got one, getting paid to go skiing. And of course now it's all automated with electronic sensors. But we're now finding that the snow melt started weeks earlier in many of our stations. And so April 1st is no longer the start of the peak of the snowpack. Most years. Some years it still is. I think it might have been last year, but not in most years. And so as a result of this increase in temperature, which this is an average for the entire West that they show, we're seeing our rivers peak earlier on the order of a couple of weeks. That spring peak of snow meltwater is peaking earlier. You know, there's a lot of variability, of course, with the rivers around the West, but on average, they're about 2 weeks earlier, some as much as 4 weeks earlier. And so this is what we're seeing with these warmer March temperatures triggering the early snow melt and then starting this sequence of events that takes us through our summer. Now, a particular part of the stream hydrograph that I got interested in about a year ago, and I've got a student now working on, is what's happening to those low flows at the end of the summer, the August minimum flows of the rivers, because that's where the trout get in trouble. And this is the overall statistic. This is work in progress of what these 7 rivers have shown over the last little over 50 years. Every single one of these, the trend is down in August stream flow. Every one. And this isn't all climate change. Some of this is irrigation withdrawal. But from the point of view of the aquatic ecosystem, the net result is the same, is that we are watching the dewatering of the Montana rivers. And you might have seen, we had a big piece on the Lehrer NewsHour on the national PBS that turned out to air on Halloween night. And it was a 9.5-minute piece on Montana trout and drought, it was called. And if you want to take a look at it, it's on a website called climatecentral.org. All right, I want to turn now from kind of the pure hydrology and start thinking and letting you know what I'm seeing about some of our ecosystem trends. First thing is the growing season's getting longer. And so now's the time to plant peach trees because they'll make it now. I may even go for apricots next. We really have a couple-week longer growing season in Missoula than we had 50 years ago, on top of not having as low of absolute minimum temperatures in the midwinter. So we're really getting a more benign climate for gardening and agriculture. As long as you can water your garden, you're in business. Things are better than they were 50 years ago for growing gardens. And all through the West, as you can see in this graph, this is true. And our satellite imagery shows this at a continental scale, that overall we're getting higher productivity out of our natural landscapes as the basic temperature limitation of those ecosystems it slacks off a bit with the warmer temperatures. But the flip side of this is that these longer summers are propagating water stress in our forests. The warm minimum temperatures through the winter are not killing the mountain pine beetle larvae as effectively. On top of that, we've had a history in our forest management cycles where we have a lot of forests that are maturing now to a stage where they're particularly susceptible to mountain pine beetle, and we're seeing really incredible outbreaks. Now, I haven't been up to see this up in British Columbia, and I probably should take me a field trip to do it, because I look at this map and I hear from my colleagues up there, and they just talk about millions of acres of dead lodgepole pine trees. And I have seen this down in Colorado in the last couple years. The Summit County area where all the fancy ski areas are, they've got dead trees all over the place. And so it's kind of funny that this hopped over us, and I'm starting to hear reports from people around Montana that we're starting to get the same sort of mountain pine beetle major infestations. Now, when I first got here in 1979, in the early 80s, we had a mountain pine beetle outbreak also. And so people sometimes say, well, what makes you think this is any different? We've had these before. And this really is different in the fact that it's continental in scale. This isn't just a local region. We're talking about, this is 1,000 miles from the top of this outbreak down to the bottom. And so we're talking about across the entire backbone of the Rockies, seeing a level of infestation that is not normal, is really unprecedented. We're seeing with white bark pine, same situation. This is down in Union Pass, Wyoming, just a couple of months ago. And see, I don't normally show pictures like this because I'm so colorblind I can't actually see the dead trees, but I've been told There's all sorts of brown dead trees in this picture. And if there isn't, somebody please quietly clue me in so I'll quit using this slide. But I was told this is a very good illustration of dead white bark pine forest. And down in this area, when I get up close to them, I can tell they're dead. It's only at a long distance I can. But we're seeing, again, a really unprecedented landscape and regional scale mortality of white bark pine also. And so this is part of this whole system of, I think, longer summers that generate physiological stress in the trees, milder winters that allow the beetles to overwinter more successfully, and then this coming together to these kind of outbreaks that we really haven't seen of this scope before. Some other ecosystem impacts that we're starting to see. This is a group here at the Forest Service right here in town. They're seeing that it looks like the southernmost populations of wolverines appear to be blinking out. And wolverines have a particular life cycle where they have to den in the spring in the snow. And if the snow's already gone, then they don't den successfully. And so the wolverine populations at the higher latitudes are still okay, but it appears to be something specific here to see these populations at their southernmost range starting to blink out. Now, an issue that isn't climate related, but makes it all the more difficult for our wildlife to cope with these climate stresses is habitat fragmentation. And this is a picture of the Big Sky area, places that I used to moose hunt with my friends just literally 5 or 6 years ago. And now there's trophy houses there across these hillsides. And even if they're bankrupt trophy houses, they're still there. And so we've really, I hope we're not seeing this as the future of all of western Montana, because we've lost a good chunk of the local wildlife habitat around Big Sky to just these sort of vacation home development across those hillsides. And as these animals try to cope with the changing climate and are having to move from their current habitat to a more suitable habitat, this doesn't help when they have to work their way into a landscape that is so fragmented and they really don't have the kind of cover and forage that they're comfortable in. So how do we look at the future with these climate models? And we start with the big GCMs, as they're known as, the global climate or global circulation models. And then what we do is zoom in, of course, to our little part of the world and attempt to interpolate from the global model into what we expect around here. And so I've pulled a few of these. These are fairly new slides that probably I haven't shown for too many months, so you may not have seen them. And this is December, January, February, so this is midwinter temperature difference and precipitation difference. And you see a very evenly distributed warming across the region, really across the whole continent midwinter, on the order of a couple of degrees centigrade. It's harder to interpret the precipitation trend. It appears like some of the areas may actually get more wintertime precipitation. And I wouldn't want to over-analyze these graphics, because in reality these global models don't have that level of precision. So this should really give us only a general indication, and we shouldn't be worrying about if we're here instead of there, we won't get as much rain. There's no way you can draw those sort of conclusions accurately. But it does show us that throughout the Northwest, it will be warmer in 40, 50 years, certainly than it is now. And that by and large, our winter precipitation will be maintained. Only a tiny corner down here does it suggest it might go down. Summertime, though, look at the temperature trend. Very, very unmistakable throughout the Northwest. But this is where I start getting nervous, is look at the summertime precipitation. All through the entire region, nowhere has an increased precipitation at all. Nowhere is increased. The best we maybe do is break even. And I hope this is wrong, but until we see evidence that it is, this is our best understanding for now. When we've done some hydrometeorology simulations with these forward climate results, you see things like this. Timing of peak snowpack. This is Deer Point's just in the mountains above Boise. And right now the peak snowpack is on the order of mid-March, and you see it going to December 23rd would be the peak for the year by the end of the century. And so that really suggests virtually no snowpack, no wintertime snowpack in those mountains by 2100. Glacier National Park, we still will get winter snowpack, but it will have peaked by late February, which is a good month earlier than it peaks now. When we've attempted to do more localized simulations with this, this really is just another version of the same type of information, that we see additional water stress in our ecosystems throughout the Northwest on the order of 40, 50, 60 days longer summer stress periods than they have now. And so I can't come to any other conclusion than that we are in for an incredible crunch time in water management throughout the interior West and Montana. If it gets this much warmer and yet we receive less rainfall and the snowpack melts a month earlier, you add all this all together, and it just, you can't interpret that any other way than a dramatically more arid ecosystem, really the aridification of Montana. And we're going to have some very difficult water management issues to fight with that. Some looks at I've got a couple of slides here on some impact analysis. This is one for waterfowl habitat, and this shows the historic range of the duck habitat, and then you see with the different model runs that if it gets warmer, you lose part of that habitat. If it gets warmer and wetter, you maintain most of it. But boy, if it gets warmer and drier, it is a real double whammy in terms of available water for the kind of potholes that are waterfowl habitat in the upper Midwest. And so that's the ecology and the biophysics part. I'm going to end with, how am I doing? Not too badly. With a little bit of, I don't know what you call it, social commentary on what I see coming or what I hope is coming or something like that. And so I'll just make a few, not a comprehensive evaluation of this, that would take a long time, but a couple ideas that I see important. And of course the first one has already been talked about, is that worldwide, probably the single biggest thing we have to do is quit burning coal for electricity. The single biggest thing we can do. And Jim Hansen, the leading climate scientists on the planet. I was in a meeting with him just last week, and he's reiterating this everywhere he goes, that this is a single thing that we have to stop. And of course, we have these coal trains come right through Missoula, and it's hard to ignore those now when I'm riding my bike along and I look up and here goes a coal train. You just, oh, geez. And so we certainly need to be aggressive in looking at alternatives, and this is not going to be popular. And I suspect in this crowd everybody's all for this, but I'll bet I could round up another crowd in Missoula that would be violently opposed. And especially when you get to the southeast, I realize that they don't have the wind energy potential, they don't have the solar energy potential, they've already peaked out their hydropower, they're in a hot, humid climate where they need their air conditioning, and you ought to see the map. I used to have a picture, a map of where the coal-fired plants are in America. And you go through the southeast, and that's where the real political battle is going to be, because if they quit burning coal for electricity, they have a huge fraction of their electricity base that they've got to replace, way more than we do, and with seemingly much less options than we do. And so we already can see that if we were serious, wind turbines can do quite a good job throughout much of the Northwest. As you get a little farther south, solar power is very viable out here in the Mountain West. As our winters get cooler and more of the electrical load is summer air conditioning, well, we have pretty good sun in the summer too. And so you start having your solar power peak being at the same time your electrical demand peak would be, which doesn't fit so well now when your peak demand is winter heating. But as you get to a peak demand that's more summer air conditioning, it fits a lot better. Another issue that could be good news unless it goes too far, which almost guarantees it's going to go too far, so I think we better start preparing for this now, is the potential that our forests become biofuel farms. Now, a little bit of this would be tremendous, because part of our wildfire problem is that we really just have too much fuel on the landscape, and it's been building up for decades, and yet there's not enough value to that old dead small material to do anything with it. And so a little bit of biofuel market would be very valuable to give us the finances to do a dramatic amount of forest restoration. But if we turn the entire Montana forest into Weyerhaeuser high-yield tree farms, I don't think most of us would be very happy, and I'm afraid that that's certainly a possibility if cellulosic ethanol makes some technical breakthroughs. What this graph actually shows is we computed the value of U.S. forest harvests for 3 different products. One for carbon credits, second for normal forest products, 2x4s and plywood, and third for ethanol. And you see in the 3 boxes at the bottom that carbon credits didn't do very well. And we used a fairly enthusiastic price, like $25 a ton. And yet when you really crunch the numbers, it did not stand up to the value for normal forest products, which tells me that people will only buy sell forest carbon credits for forests that they didn't want to harvest anyway. And so maybe that's good, but we may not actually be buying any more carbon sequestration. They may have done that anyway, but what really concerned me is when I looked at the ethanol value of the forests, and and this was, I think, at $3 a gallon. price. And imagine this at $6, $7, $8 a gallon. And I can imagine the day may come when our forests, when there's just a raid on our forests for ethanol, and if cellulosic ethanol really breaks through. This graph I first saw only a couple of months ago, and it has an incredibly important message to it. Because I've more than once talked to an audience and said, you know what, we should cut our electricity consumption by 30–40%. And invariably people will say, that's impossible. And just a few months ago, I saw that California's already done it. The per capita use, now certainly they have a giant population, so their overall electric use is huge, but their per person use of electricity, look at that, is half what it is in the rest of the country. What this graph tells me, when I go to California, I don't see people suffering with too miserable of a lifestyle, is that we could probably, on a nationwide basis, cut 30–40% of our electricity use by getting really serious about conservation and efficiency, the way California has been doing for 30 or 40 years. No, this is it. It isn't back there. This is really consumption. We're not talking about supply. We're just talking about how many kilowatt hours every person uses. And you see that they don't use anywhere near what the normal American does. And I have a lot of friends down there, and they tell me about things like programs where the power company, you agree to this, you can sign up to this program, and the power company can turn off your air conditioner in the middle of the day if they're starting to reach a brownout. And if you're willing to sign on to this, you get this huge cut in your power price for being willing to let them control your air conditioning. You learn that peaking power, the peak power at the total peak demand, can cost 10 times as much as what they call baseload power, as the average day-to-day electric power. 10 times as much. And so for a power company to be able to cut that demand saves them an incredible amount of money. And most people don't understand that at all because we don't ever pay attention to supply-demand dynamics in our electric system. A smart grid would allow us to do things like this, and this graph tells me that we have a tremendous amount of really easy, technologically easy things we could do to drive down electricity consumption before we get to the hard stuff. Because they've already done it. And when I think of getting rid of coal-fired power plants, and then I look at this graph and I start saying, maybe we would have a chance by just using less. And as I say, Californians don't seem to suffer too pitiful a lifestyle, so this isn't by living poorly. This is one of my favorites. The easiest thing you can do to get a more high mileage car is to just go slower. It's amazing how many people don't understand this. That any car, I don't care what you own right now, well, maybe you don't own a car, but if you have a car, I can almost guarantee you that the difference in gas mileage between driving 75 and 65 is probably 5 miles a gallon. Because on this curve is everything from a Prius to a Mercedes. And every car you see follows effectively this same trend. And I've talked to lots of people that have done this, and just slowing down to 65 or even 60 if you really want to be an eco-nut, and you gain 5, 6, 7 miles per gallon in your car, and it lasts way longer too. And it's a way safer, as we all know. So this is the pickle we're in right now. When we did the IPCC model runs projecting the climate to 2100, we used these set of what are called emission scenarios where we guessed or projected how much carbon emissions humans would produce. Well, the reality, we did those model runs in 2000 and 2001. And so since then, look at where the actual emission track has gone. We have hit the worst, the highest emission, what I call the Dick Cheney scenario, we have been hitting over the last 5 years. I mean, this is, you know, our fantasy that we could be down here in these conservation sort of scenarios doesn't hold up one bit looking at reality. Now, what I'm waiting to see right now is with this global economic downturn, whether we'll actually see it in reduced emissions. And I like to hope in the next year we might drop down this curve a ways, because boy, we better start dropping down somewhere on something, because this is as bad as the IPCC could imagine. They couldn't imagine anything higher, and yet that's what humanity has done over the last 5 years, 6 years. We struggle with knowing where it all goes. People don't understand this. But about half of those emissions end up in the atmosphere, and that's what we measure with the Keeling Mauna Loa curve. We measure the CO2 that stays in the atmosphere. Over half of it goes in to the ocean and land carbon sinks in ways that we don't fully understand and that might start slowing down. And so the biosphere right now is doing us a favor that it may not continue doing forever. And that's what one of the things that makes us as global carbon scientists a little nervous is these uptakes rates by the ocean and land are not guaranteed to continue forever at all. And they would just make things worse all the faster. And so what we're really looking at is the specter, this is for the Pacific Northwest, of a temperature that on the Dick Cheney curve, we could end up being 10 degrees warmer by 2100 than we are now. And really the best we can do is to still end up down here on the order of about 5 degrees warmer. That's the best we can do. And that's particularly because, remember, we have 50 years of heat energy that's already in the ocean. New energy in the ocean. And on top of that, you just saw the emission trajectory of the world over the last decade or so. There's no evidence in the slightest that anything's slowing down. And so we fully will see that 5 degree warming by 2100 is probably the best we can hope for. And that really, when we pull back from the Pacific Northwest to the entire global trend, you start seeing the specter of us ending up, you know, way the heck up here. Here's 1,000 years worth of global temperatures, and you look at where we are now, and then you look at where another 100 years of the Cheney curve would take us. And as climate scientists, we can't guarantee the stability of the Earth system at that level. We just don't know what might happen. Come on. I've killed the computer. Yes, it is.
The power must be too expensive.
Yeah, that's right. All right, I'm going to come out and go back in. That's usually a way to wake it back up. Because now we have to start talking about some solutions. And particularly, in this case, a carbon tax. And of course, I have never yet met a person that just stands up and say, I love taxes. And so And yet, we recognize that without taxes, we don't have a functioning society and organization to governance. And in this particular case, a carbon tax is probably the mechanism that best propagates the costs of carbon emission across the economy in an appropriate way, that particularly as the price of the carbon goes up, then the demand goes down. And what happened to gasoline last year? The price went to $4 a gallon. We, for the first time in history, Americans drove something like 100 billion less miles, and that at least aided the drop in oil prices because the demand dropped off. So this works. We know that increasing prices encourage people to use less of anything, and increasing prices for carbon-based fuels is a very good way, a very good incentive to get people to use less, and that's the start of taking us down the cycle to drive down these emissions. And yet this is wildly unpopular. I really can't wait to see if Barack Obama is a clever enough politician to get Americans to swallow this. Because I think this is what ought to happen, but I don't see how any politician could sell it to the American public. I'm going to tax you a carbon tax, I'm going to double the price of gas, and it's good for you. You think he's going to make that fly? We're going to find out soon. I know part of his energy policy has to be some sort of carbon emission taxation, or else it's not an energy policy. But I don't know how he's going to sell it. Some of you in the audience might remember this book. You see, I got this when I was an undergraduate. It was one of my textbooks in 1972, The Immortal Limits to Growth. I met a Canadian author at a meeting in Sweden just about a month ago, and lo and behold, he's just come out with a book, Managing Without Growth. And I spent the week with him, and it really was interesting to talk to him and have him take us back through the history of government policy on economic grounds. And he says, you know what? Every government on earth now, an unquestioned tenet is economic growth. And he says, that didn't happen until the last 50 years. Why have all these governments become convinced that one of the cornerstones of government policy has to be economic growth? It is quite a read. I read the whole book over Christmas, right as it came out, and he really argued that humanity, particularly the developed Western world, really needs to revisit the very principle of why are our governments obsessed with economic growth. Because we know it can't be sustained forever, and in fact it may look like we've already gone over the edge. And so I'm hoping to get this guy out here for a set of lectures this spring, and if I can get him, obviously I'll advertise it widely, because he really had a wider array of arguments about how you organize society and government without this growth obsession. The best thing I've read since 1972. And so I guess I'll end with my, I hate to call it standard ending, and see, let's see, where are we oscillating? I've been in step 4 a fair bit in the last few months. Maybe come Tuesday, I'll get to step 5 once again. But this new administration has an unbelievable task. But I also realize, and I think they realize, that it's only in times of turmoil that you have the chance to really forge a new path. And so we are both nationally and globally in that level of turmoil, that this may be the perfect time to start the world on a dramatic new path, and we better. I think you see from the climate projections I show that anything resembling the Dick Cheney curve for another 100 years, and it's all over. So I hope that's a good enough fill-in.
Well, thanks again, Steve. I think we've got about 15 minutes if you're willing to take a few questions. Anyone from the audience over here? Someone had their hand up earlier over here. Did your question get answered? Would you like to ask?
No.
Well, this isn't very high level or theoretical, but when you were, I was interested in the thing that where you showed what was getting, the blue and the red bubbles of what was getting hotter and what was getting.
Oh, yeah.
There was one place that looked like it's on sort of right around Hell's Canyon,
Mm-hmm.
or Devil's, yeah, on Oregon, and I'm wondering, can you be more specific about where that is? Because it was a big blue, and so
Yeah.
it's getting more rain when everything around it isn't.
Well, one of the things you learn whenever you start looking at climate trends across a broad area like the West is there's always a few stations going the opposite directions for reasons that you would have to go to each one of them and figure out what's up. And sometimes the station record is bad. You know, like the Great Falls temperatures turned out to be junk. So that paper, I hope they scrubbed all their data, but it's all awful hard to do. So some of those may not be real. Others, there are just local peculiarities in microclimate that will cause a station to be getting more snow for reasons that are really hard to follow. And so anytime I show a map like that, scrutinizing any given point I find is dangerous, and of course particularly when I don't know what the point is. But the real broader climate message is what the majority of the points are doing.
Steve, if we all did the right thing by the end of this year, let's say, and we got emissions way down and we're still on a momentum curve, can it be stopped, reversed? I mean,
Probably the theoretically best we could do would be 1 more degree C of warming, because we think that's already in the ocean.
Yeah, Steve, I wonder if you could talk a little bit about the global climate models and variability and frequency with which we can expect extreme conditions, both in terms of storms and extreme cold and extreme drought and extreme hot. I mean, you already demonstrated extreme in high temperatures, but is it consistent to have extremes also more often in cold temperatures?
No. And I see that written once in a while, and I don't know where they get that. On the low temperature part of that spectrum, you're still going to get some, but I don't understand how they would expect to get a greater frequency of colder temperatures than the historic normal, other than the natural variability of the site, which you can always go into a cool trend in the inherent natural variability. But from a climate trend perspective, I don't see how you'd ever come up with it.
Yeah, but I wasn't talking about trend. I was talking about extremes altogether. So,
Yeah.
Not that you're going to have extreme cold more often,
Mhm.
but that when you do get extreme cold, it's going to be cold. I don't know whether that's true or not. I'm just asking.
I don't know why that would be true. So if I had to guess, I would expect that not to be true. We're still going to get cold weather, obviously, and also I'll say that these climate models, these large-scale simulations are what I call a central tendency model, where every function in that model is basically representing this central tendency of the coupling that it's calculating. And so they tend to really not represent variability very accurately at all.
A quick technical question. Don't want to sound like a skeptic, but I was interested in your Western Montana city graph of the temperatures over the past few decades. Are those temperatures corrected for urban heat effect?
Yeah.
They are. Okay.
Yeah.
So you already described.
And there's been a number of studies. The National Climate Data Center in Asheville has done a tremendous amount of work in correcting all our national temperature records for the urban heat island effect. In fact, their director, Tom Carl, that's what he made his career on. And so that is well understood. There's certainly stations where urban heat island effect has influenced the raw record. And so it's absolutely a real physical phenomenon. And you can easily see center cities 2, 3, 4 degrees warmer than the surrounding countryside.
It would seem, my understanding is that that's not true for all weather stations in some developing countries. Or something. There's been some disagreement about the magnitude of increase because sometimes that correction has not been done.
Yeah, exactly. And of course, when you start looking at individual records, other exciting things happen. If you go to an urban area that is out in the desert and highly irrigated like Phoenix, then it goes the other way.
Steve, I'm going to take the microphone holder's prerogative and ask one of the most obvious questions that I always get. And it's more of a comment, and then people will often say that global warming is part of a natural trend. And I wondered if you would tell us how you would respond to those folks who say that climate change isn't being caused by humans, but it is being caused by natural trends that we've seen over centuries.
Well, basically, as they build those climate models, they build in all the natural variability that we understand. The Milankovitch cycles of the Earth orbital dynamics and wobbling of the axis of the Earth, all that's built into those models. All the ocean circulation dynamics and El Nino dynamics are built into these models. And so all these the variability in solar output, the solar dimming sort of arguments that I hear. We know solar output to 8 significant digits. We have a satellite above the atmosphere that measures the solar output to higher precision than about anything you've ever seen. And so all these sources of natural variability are represented and covered in these models. And they don't get it all exactly right. And they're not right everywhere, but they cover the trend of every source of that variability that we can recognize. Now, you look in the past and there's been additional sources of variability. Major volcanic eruptions, major meteorite strikes. If you go really far back, the continents weren't even in the same place. And so you can look at variability through history and it's real. But that variability for our current time period is well represented in these climate models, and these climate models can't track the current temperature record except by adding the greenhouse gas emissions.
Thanks. In the front,
Yeah.
let me get this lady over here real quick. She had her hand up.
So it's trendy right now to really look at the carbon footprint in bad civilized countries or more highly developed, that we are doing that. If I remember right, limits of growth also talked about population control, and that's not PC. So how does just limiting how many humans there are on this planet Earth going to help?
You know, that is, you're exactly right. Nobody talks about that. And I actually didn't pay enough good attention to it until I gave a talk to the Western Regional Planned Parenthood Conference a few months ago. And before I went to that, I got curious and dug up the scenarios from the IPCC report. Well, lo and behold, part of the Dick Cheney scenario also had a population increase to 14 billion people. Now, the mid-level scenarios expect about 9 billion. We're at 6.3 right now. One of the things that I see would be a very interesting, shall we say, international diplomatic strategy would be to talk to a developing country and say, you know what, we won't bug you about your carbon emissions at all if instead you agree to cap your population. That might work better, and it might be something they could better control, and it absolutely is an underlying engine for these trends, is population, absolutely. And it really isn't hardly ever talked about.
Well, we've got the food out, and I know that the wine and beer is ready, so I'd like for everyone to give Steve another round of applause. Thank him. That's a way for us to thank Steve for coming out tonight from his home. We're not just giving Steve a 2008 wilderness, or 2009 wilderness calendar. That wouldn't be appropriate. So we're gonna at least send Steve and his family to dinner at Scotty's table. Thank you, Steve.